Hello, everyone. Good morning in day 8. I'm just waiting for a couple of guest members to join, and then we will start the webinar soon. So just bear with me for a while. Good morning, everyone. We'll make a start, and as the guest lectures join, we would make a go. So I'm going to share my slides. Can you please confirm that you can see my slides? Today is a different setting. Actually, I am in India, Roorkee. So I am in the same time zone as you guys. So it's my pleasure to present this lecture in the same time zone as you. So, so far we have presented a large number of use cases of generative AI. And today's module would be wrap up and would be futuristic thinking in terms of how we can look forward to it. So the plan is that I would kind of wrap up, give you some important thoughts to consider, and then we will have two speakers lined up. Dr. Bashar, who had presented two modules, would talk about this very current LLM DeepSeek that has been just recently publicized. So he's going to talk about the more details on that platform. And we also would have a presenter, Stanley, and he is going to talk about hallucination detection. So I will wrap it up, and then we will see when Stanley joins in. Stanley is going to present that, and then Bashar is going to present. I'm trying to contact Stanley, but hopefully, let's say he joins soon. And so so I'll go first, and then Stanley would come and join it. So let me check. Um, yeah, because I received the list, the link very last moment, so he must be trying to connect to it. Okay. So as we have seen quite a large detail of LLMs, and we saw many general purpose applications and also some specific applications. So for example, like general purpose applications, like you ask a question, for example, like summarization is one of the very common use that LLM is used for. If you have some topic or some picture on the wall, and you would like to ask them to summarize, they would tell the scenic story behind that. Or you can even ask the question answer. For example, how is air traffic controlled? Or how do you become an air traffic controller? Are these questions asking the same thing? So it has the capability to compare and contrast and then answer it. At the same time, like it can use as simple question and answer system, where it can question what type, who type, why type, or list type. And this is all very older technology kind of knowledge base. So they have got all the answers stored in the form of historical data, but it has got a reasoning capability. So when we ask a question, it relates to that knowledge base and then answers it. And also you can ask for many suggestion, like recipe suggestion and things. So in a way, it is a very full recommendation engine that actually talks about what could be the produced as an outcome. So when we do have this big monolithic system that is like it has very, very general purpose knowledge. So what we want it to create the agent that behaves in accordance with what a human wants. In the one of the previous module that Stephen presented, we saw some examples where we can make these LLMs to act like how we want. We can make a persona based on the profile that we want. But when we do that, there are lots of questions, similar as like personalization system or recommendation system. Who is the target? How are we determining what they want? So this problem, we call it alignment problem. So if we have AI system with the skills that we find important, how do we adopt these systems to make sure we use it in the same capacity as we want? So if there is this HHS framing by Askell et al. That's helpful, honest, and harmless. So this kind of agent, we want these LLMs to be. And this problem, we call it alignment problem. So we would, of course, the first important thing is whatever we want their purpose, that purpose should be fulfilled. It should be helpful to our purpose. Then the second one is honest. So that's where hallucination comes in. We would like it to be the factually accurate information. acknowledging its own uncertainty and limitations. If it does not know the answer, it should train to say, no, I'm sorry, I don't answer, rather than coming up an answer that may not be factually correct. So we would look a bit more detail in today when Stanley present in terms of how it could be done. And of course, then we looked at the one of the previous module that Joy presented in terms of the safety guardrails. So, for example, like in one of the project that Joy presented with the Queensland government, we got our own ethics principle there. We got our own rules, what we want to present, what we don't want to present. So we would make sure that LLM is being honest but avoids this toxic, biased, or offensive, or something that does not align with the organization philosophy. So that's what these systems had to be. So for example, like in terms of helpful, if the question is what causes the seasons to change, so how we can do, we can, during the training, multiple answers are returned, and then we can have this reinforcement learning where the wrong answers are labeled as incorrect, correct answers are labeled correctly, and then the LLM learns itself. In terms of honest, for example, is it possible to prove that P is in P equal to NP? Then no, it's impossible, or this is considered very difficult. So you trained the LLM that you would like to use in your organization to the extent that you want to be. So you define your own boundaries in terms of helpful, honest, and harmless, and then do that. So let's see some example in terms of what are some of the constraints or the complexities that these systems handle. So for example, we all know about a fake and all those AI generated news. So like this, a college kid's fake AI generated blog fool tens of thousands, and AI that writes convincing prose risk mass producing fake news. So we have seen so many of fake news. Recently, it was really disturbing in terms of the creativity that Drake Weekend collaboration, and they create a new song, and like everybody got really upset. So what is really the boundary of this fake, like this kind of news was quite fake during the election time, and it can change so many of that. It can, the another issue with LLMs is that is a constant um, uh, discussion point, that are they useful to the community, or would they become harmful in a way that we lost the job? So it's always a point of discussion. Is AI good or bad in terms of humans? Would it take, so in Australia, every time when you go to a factory and talk to the owners and the people over there, laborers, there is always a fear that the AI technology would come and would take our job away. So, for example, news like this one does not help. Goldman Sachs predicts 300 million jobs will be lost or degraded by AI, or something like that, that the automation would let these jobs to be lost. So the new technology, like when industrial evolution happens in factory settings, um, a major disruption happens. So in the same way, this AI technology is another major disruption that would change the field, but it has to be taken as positively rather than more negatively. So there are always some pros and cons in terms of how will AI impact society. So for example, impact on the workforce, um, uh, personalization is one main thing. you have got big general purpose system, but it enables personalization. So what is the difference? When we used to use these AI technologies 5 or 10 years back, we would generate an AI system for each function. So for example, like if we are talking about recommendation, if it's a movie recommendation, we would have one specific recommendation system. If we have a dating recommendation system, it would be another personalization systems that we need to develop. There were so many systems, so it's an old problem that there would be end up having so many legacy system that only the users of that system know about them, and the small group of developers only know about that system. There is no general purpose thing to it. On the other hand, when we have the LLMs like big systems, then the same big system can be used for multiple personalization tasks. Some of that was detailed in Stephen's talk. So it enables personalization. And as we go forward, this is one area where we can really improve LLMs. So right now, LLMs are trained to give very generic response, but that's where we user using those open AI systems or open source system and then built more and more applications onto that. Of course, automation and efficiency. Some boring work that nobody wants, AI can do this automation and efficiency. And Gen AI is really cherry on the top, that it does so good that you don't have to write the same stories, it can learn from you. And human then just have to observe, monitor, refine. So you are not doing things from scratch that would take 7 days. You would only spend a couple of hours, and you are good at it. And accessibility, like when we have these proprietary systems, legacy systems, only few people can access. But now with these big monolithic systems, accessibility has really become quite easy there. But the counter arguments there, that when we are automating, certainly some jobs would be let. There are some ethical concerns. There are some over reliance and private and security. So, like in some of our modules, we cover those ones. So yeah, we know that hallucination is created. We know some harmful contents are created. So we have to make sure that we do not over rely on those responses, but we generate the systems that can do, like the guardrail and something like that. There is always cybersecurity threat, and as we know that once a data is online, nobody really ever deletes until it is very targeted exercise. So whatever data we are giving to LLMs for training, we have to be careful that it is of high quality there. Impact on the environment is another issue, that how does it really impact? So for example, we know one Google search engine, Google search query is almost equivalent to 1 hour 60-watt bulb. So that much energy that we used to waste with one Google search query. And now one ChatGPT query is 100 times more than one Google search query. So that is really a concern for the nature, environment, CO2 emission, and all those things. We talk about net safety, net zero, but as we go towards these technologies, it's not just the building cost, because people think that once LLMs are built, it's all good. But every query that we use, we again spent a lot of carbon emissions. So for example, this Llama 2 that we have seen some of the training like that. This is a ChatGPT like model, but from Meta, it produced 539 metric tons of CO2. Llama 2 being open source, we have more data, more stats about it. So larger model use more energy during their deployment. Then there is very common point, is AI going to kill us all? We see all Hollywood movies and so on, and then there is this narratives around AI that it would become more intelligent or super intelligent with us. But I'll put this quotes from Tim Berners-Lee. So many of you would recall Tim Berners-Lee, who is called father of internet, or at least the semantic web. And as he puts it very rightly, no one has ever encountered a super intelligent AI, so it's hard to make categorical statement like this. And there are likely to be eventually be billions of intelligent AIs in the world with a variety of capability of goals. And many of them will be benevolent and some may go rogue. So there is a possibility, and that's why every single AI application that we built, we have to be very, very mindful that what we are going to do. So it seems easier to minimize the harm a super intelligent AI would do to prevent the rogue AI systems from existing at all. So we are not really any way that this could happen there. There was some research with Australian Research Council. So what they did, they assessed GPT-4 ability to conduct many tasks. Some of the tasks that was that conducting a phishing attack against a particular target individual, setting up an open source language model on a new server, making sensible high level plans, hiding its traces on the current server, using services like TaskRabbit to get humans to complete simple tasks. And then they concluded that they found these LLMs to be ineffective at automatically replicating or acquiring resources or avoiding. And you have seen in many of our use cases that still 100% is not achieved. There is a lot of scope that could be achieved and that could be done. So in parting, I'll kind of put some thoughts to summarize this module, that we have to really assess that what is a bigger threat to humanity, whether it's a climate change or Gen I, or is Gen I really a threat or an opportunity? We need to weigh what is really bigger and how do we use these new technologies. Those are very disruptive, but at the same time very helpful. So we use them in the honest way and harmless way. The most important thing is that who is in control of AI? We know that the problem of technologies comes when there is not much controlling guidelines. So we have to make sure that the data is used securely. All risky technologies has historically been strongly regulated. So when the third industry revolution came, there were strong regulation in terms of how industries are being used. So in the same way, we have to have a strong regulation. So there should be a balance of technical research as well as this regulatory framework research. So researchers from law, researchers from business, should also be part of these new technologies, not just the IT and engineering research who are developing these new technology there. So this is very important that, and as I was summarizing in week 1, there is so many opportunities available with this new technology. We should be using it. It has got so great benefit. that the benefit assess higher than the risk, but we still have to really make sure that those risks are not really overlooked and taken care of that. Um, so I think I will park going for this open discussion, and I can see that Stanley has joined now. So I think I'll stop and would invite Stanley to present the research on hallucination detection. And once Stanley finishes that research, we'll have Dr. Bashar talking about this new area. So Stanley, you would be able to share your screen. You can turn on your video now. Thanks, Stanley.
Hello, can everybody see me? Sorry, there was a hiccup on how to sign in.
It's okay.
So one of
Yeah.
our panelists has sacrificed her account to let me get in. Yep. And now I'm just going to share screen with you, and please let me know if you are able to see it. Yep. Is everybody able to see the screen?
Yep, it's all good,
It's all
Stanley.
good.
We can see your screen and can hear you.
All right. So in that case, we'll make it a start.
Thanks, Stanley.
So yep, thank you. So, hello everyone. So as what Dr. Ritchie has told everyone, the topic I'm going to present is on the topic of um large language model hallucination, LLM hallucination. In fact, you might have already heard a little bit that has been mentioned by Joy the previous day about this, and I'm just going to go a little more deep dive into this topic. So just quickly about me, I'm not a chicken. I'm just putting a chicken over here for a picture for amusement. The fact is that I am a master's student part-time, which only joined about 3 months ago. So the topic I'm just going through about is more or less from my literature review, and in particular on the hallucination detection session. I'm also working full-time in elsewhere, a company called Customer Driven, and my background, in fact, is not so much on the data science, but on the topic of physics. But I just switch field. All right. Just the same slide as you already seen from the other talks. This is just a disclaimer and the photo of our group. I'm not yet in there, but yeah. Anyway, I do exist in the group, just in case you are aware. Anyway, let's go through the agenda. So what I'm going
Sorry, I
through.
think it's my mistake, Stanley.
Huh?
I didn't realize that you were missing, but yes,
That's
you
okay.
are
Yeah, that's
always
okay.
part of our group. There is
I
a
think
space.
I'm not
I
the
think it's
yeah.
a whiteout. Yeah.
That's okay. I think we also have another addition of our group that hasn't been
Yeah.
put in, so it's totally fine. I can understand. It's just a slight lag. Um. So so again, just going through the agendas, the topics. So I'm just going to quickly go through a little bit about the background on hallucination, what they are really, and then the types of hallucination people has classified into, the cause, and then the detection methods, and then the mitigation. And again, my research focus currently is on the detection, so I will go a little more in detail on that one, but I will try to go through all of them as much. All right, little bit of background. Hallucination. Hallucination, in normal term, it's really on something that we seen and that's not in the reality. And in terms of the machine learning, I think some of you or all of you, I don't know, may have heard this famous example. If you ask the ChatGPT or other language model on how many R words in strawberry, often they will actually give you two. And I only literally tested this week. Still, it's still happening. Strawberry, just in case you don't know, there has three strawberry R's in the strawberry, but most of the LLM, including most of the model or some of the model of OpenAI, Gemini, and the most recent example of this DeepSeek, they are still on the fact on they believe there's two. And so that's one of the famous one of the hallucination, which is actually a special one. We'll go through more of those later on. Again, the term hallucination arises because of we all experience it basically. Like if anyone who has already started using ChatGPT or any other language model, you may more or less finding that you know, the language model often make up stuff or just out of context or various of different type. It is a critical issue. It is, and it's a very recent, relatively new issue because, you know, people notice that when the language model comes up, and big issue because that influence our confidence on using LLMs, and that's also part of the reason many you know, there's many restriction on using LLM in different uses. Anyway, so what are LLM hallucination? So one of the definition, there are many definitions floating around, and they all vary slightly. Like the version, this one is the one I use. Could be slightly different to the one you may have seen in the previous lecture. But this one states that the model generate content that's nonsensical and not unfaithful to the provided source content based on the paper on 2022. So the two keywords are nonsensical and non-faithful. Nonsensical, according to Google Dictionary, if you search it, basically it means it has no meaning or it doesn't make sense. So basically that means the model create something that doesn't make sense or doesn't have meaning. And then non-faithful, what does that mean? According to, again, dictionary, it's engaging in sexual relationship in a person in relate to partner. I mean, aka cheating. I mean, okay, that's not what it means. Of course, in terms of LLM, what it really means that it's non-faithful to the user instruction. Again, in that case, we can then turn that into a definition. Just before we go into that, you may have seen this version, this version of definition, which actually this one is the major, the main one that people has defined hallucination as, and you have seen this in Joy's talk as well. Intrinsic and extrinsic hallucination. So intrinsic means it's contradicting the source, and then the extrinsic hallucination is means that the LLM actually creating content that is not verifiable from the source. Basically, it's making up stuff. Both of them, if we're using the definition before, it's more or less relating to the unsensical types of hallucination. Then the version I am actually going to use is based on the paper on 2024, which they extended the definition of hallucination into factual hallucination and faithfulness hallucination. Factual hallucination pretty much covers what we have for that intrinsic extrinsic type, but this paper extend the definition into faithfulness hallucination. That's saying this definition means that if the LLM does not producing output that is consistent with the instruction or the context or the logic. Basically, logic conflict will be classified as faithfulness hallucination under this definition. So just quickly showing you examples of those. Factuality hallucination, that means that, again, as what we say, it could be either the contradiction of factual, aka the output is incorrect, or fabrication. That means that the output of the LLM give data that cannot be verified by the input. Fabricating. And then this next type is faithfulness. It can be either be inconsistent to the instruction. For example, in the example we have here, if they ask you to translate the question into Spanish, but however, it just gives you output in English, then obviously it's not doing what it was told. And that we call that faithfulness hallucination. Or in the context, so if we are trying to summarizing this tech context, however, it give you something that is just not there. So it's not summarizing in the correct way. And also, lastly, you have the logical inconsistency. So if there's logical flaw in there, then in this paper it was classified as faithfulness. There is overlap. I mean, now when you're going through this, you may have seen that there could be some overlapping, which is also what I see as well. But again, this is a really new field, and then the definition that may still change ongoing, and we may have come up with people may comes up with even more better definition. It could be possible. Cause of hallucination. There can be multiple different causes of the hallucination. The depends, and it can be coming from all different phases during the training, and so it can be either coming from the data, like imagine we training data with bias and misinformation, simply incorrect data, then of course LLM will output incorrect data. And also there could be updates of data if if it's trained by the outdated data, then of course there could be a hallucination. But like as example, if you ask some of the older models to answer you like who are the current presidents of US, then depends on how old it is, they can reply you saying Biden is, or if it's an even older model, it can go back to Trump, but that's because the first presidency. Also, it could be there could be issue with knowledge boundary, like if you simply didn't train it with the data that they know of, then they couldn't answer you the questions due to knowledge boundary. Or there could be an issue with once after fine tuning, that you have new knowledge and it either conflict with the old knowledge or the model confuses itself. You could actually also cause hallucination. And also issue can come from training. Like in each different phases during training, you could actually have introduced hallucination. Like just as an example, if we're using ILHF, reinforced learning from human feedback, and if the human annotator give the incorrect feedback, of course, that will also introduce hallucination. So it's training, pre-training, if we're giving data in a different way, different training, and fine-tuning, then it can introduce overfitting, which actually also introduce hallucination, because it may be overconfidence on the knowledge they got. That's during the training phase. The cause of hallucination may also introduce during the inference phase. For example, as we all know, LLM have inherent randomness introduced from the softmax, the probability of the output. So there is inherent randomness in the output, which could cause hallucination, because some output may not be correct and some could be correct. So that is one big source of hallucination. There is a specific types of the detection method that's associated with that. Overconfidence, that means that saying that, for example, the attention of the input words on the tokens of the input may cause overconfidence, because if the attention is on the incorrect token, that may generate incorrect result, and then causing the model to be overconfident. Other types of cause of hallucination may be the softmax bottleneck. That is saying that when we're doing the softmax, there is a limited numbers of output that we can have, and then if the possible output is beyond that, then there will be certain amounts of output that may not be able to generate, and which they call it softmax bottleneck. And then next one, reasoning failure, which, like when the model is trying to reason the output, and you can sometimes see, especially when they're doing maths, often they just give you the wrong answer because the reasoning just fail halfway through. And we just saw an example earlier when we were going through the faithfulness. And other types of hallucination. In fact, the first example I gave you about that R's in strawberries, that was actually another types of hallucination. It's because of how the word is tokenized for strawberry. And when we tokenizing the strawberry, often the model doesn't actually tokenize character by character. So it doesn't, because of that, it doesn't actually pick up how many R's are there, because straw often tokenized as a word itself, which is not a R, and whereas the R's, and often because of that, they pick up two R's instead, and that is another types of cause of hallucination. All right, that is the cause, a quick going through with the cause of hallucination, and then we're going to go to next, which is the detection of hallucination. Detection, there are many different types, and I'm just going to go through three of the types of detection methods, which is the fact-checking, the uncertainty estimation, and then the model probing. Fact-checking, based on the definition, from the word, we are trying to check facts on the output, and to see if we can determine the hallucination in here. So in this one, there are many different approaches on these methods, and currently this is a very rapidly developed field. Again, like as you can see, most papers are very recent, and it can be ranging from we are just segmenting the fact, outputting the so when we in segment, so Min et al. Propose a method which actually by getting the LLM to answer the questions, it extract different facts from the from the answer, and then simply compare with the knowledge system. And in this case, they're using the Wikipedia API and just comparing how many facts that the output is correct. That's a very naive method. And people has developed from that method, for example, again, Sang et al. Use the similar idea, but instead of just compare that with a knowledge base, they use the fact, and then using the same fact, they create another answer. And then by combining the answer that the LLM is, a question, sorry, a question that based on the fact, and then ask the LLM again to see if the fact is correct, and by combining them to confirm how confident LLM is to answer this, on this fact that they produce. And then also the next paper, chain of variation, is a little similar, except instead of just creating answer for the atomic facts, it's creating the whole sentence, and then asking the and then create a question again to the particular sentence that the LLM is generating, and then see if they are contradicting or how confident they are. Again, we will go through a little more detail on this one in my next slide. Fact checking also have variation methods. So either ranging from human annotator, or they just simply using a separate LLM prompting to question itself, to question model itself to see if how well, how confident, how correct they were. And also that can go one step further, like using the model to evaluate itself. So again, through prompting. So again, a little more detail on, fact checking, and one of, like, lots of them have similar approaches from the current paper, and this is just one of the example. Again, it's called the chain of variation. So in this example, we can see how it was done. So first, we start with a query, questioning how many politicians that's born in New York. And then first, LLM, the model, will actually answer with some numbers of politicians that was born in New York, like Hillary Clinton, Donald Trump, Michael Boomerang. Sorry, I don't actually know who he is. I know it's first two. And then the next thing is using prompting to actually separate each of them and create question each. So again, asking the model itself to see where is Hillary Clinton born, where is Donald Trump born, where is Michael Boomerang, Bloomberg born. While doing that, there was studies showing that by asking individual questions to the LLM is actually turned out to be more accurate than a general question. That there has been research on this. So there's a lot of approach on separating bigger question into smaller question. And then by the model then answer each of the question. And in this example, you can see that Hillary Clinton is actually not come from, not born in New York. It just self-explain, answering the question. And so is Michael Bloomberg. So in that case, by combining this answer, we will actually be able to create a final response with more accurate response. So this is how what this paper has proposed, and again, it happened to similar approach has been proposed by different papers in slightly different variation. And just quickly going through the result, In here, COVE is their jointed and their proposed response, and as you can see, it's better. They produce better F1 score. Fact score is a proposed is a matrix that's created by the paper we have mentioned previously, the paper by Min, by comparing the fact against the Wikipedia output. And in here, the paper shows improvement even compared to the chain of thought that built in natively in the Llama chat version. So it shows some promise, although that F1 score of 41, 48. All right. So the next types of hallucination, we are just moving on to the another types of hallucination detection methods. So as what we have mentioned before, model LLM, they all come in for inherent randomness. So from the same output, often the model will actually produce multiple different output, and this one is by looking at how uncertain the output is. We can see how confident the model is to the query. So of course, if there's a very low uncertainty, then we can see that the model is very confident with their answer. And there are different way of probing about it. One is simply just look at the softmax value, like how probable, what are the software max output, and if it's, very high. If it's very skewed to one particular output, that means it's very confident. Concept guessing, basically using the LLM to prompt the to prompt the answer and then give an explanation, using the explanation to recreate the original concept. So if they can do that, then that means it's really confident, because that means one explanation can reproduce what the original concept is. There's no variation then. And then the next one, which is an interesting paper from what I believe, Yao's et al. What it does is that it describes the hallucination as an attack. So, and basically attack of, I guess, reality. So what the paper is trying to do is by having the query and the output, it vary slightly on each of the token, and to see how much the token have to be varied to give you a false answer. So to see how each of the token is relating to hallucination. Like certain keyword, of course, will be more important than the others. So those one will be more prone to the attack. Like, for example, if again, going back to the presidency question, like if we change the word Donald Trump to Biden, then of course that would induce the incorrect answer. As example, then those would be more prone to attack by the hallucination attack. So that's the approach on this paper. Semantic entropy, that's another one, basically estimating how confident they are, but looking in the semantic level, which I will have the next slide will be on this one as an example. I'll go into more detail. And uncertainty estimation is, again, there are many research on this, because it can be done through just the API code. So if we have a closed model which we can't actually look at the model itself, such as a OpenAI, we can only access through API code, then we can still check how confident they are by, for example, we just taking multiple response, sending multiple API call, and see how consistent their response is. And also we can compare in tokens level, like just extracting each of the token on the response and compare. Or we can make a direct or indirect query. That means that if we can make a direct question and then we can ask another indirect question that's supposed to answer back to the same query, and cross-checking to see whether how consistent the model is in answering those. Or we can comparing different LLM or using one LLM to evaluate the others to see how good they were. So here are the different types of methods that also look into how consistent the LLM is in answering the question, and then we can see how much they are prone to for hallucination. So again, one of the paper, if you have got the slide, I just found out that I accidentally used the wrong reference. So that is I have corrected reference here. But the content is correct, but I just accidentally used somebody else's other paper's reference. Sorry, apology for that. Again, there are similar paper on this, but this one is the one I picked because it's coming from Nature. Semantic entropy. So basically, the paper claim is to detect the configuration types of hallucination. So how confident the hallucination, what their definition on configuration is just how consistent, confident they are in the output. So as an example, in this screenshot, the question was, where is the Eiffel Tower? If you just simply take by the answer of the from the LM, you may have very different many different variation on the answer, but they all point to the same thing. So what this paper suggests is that instead of just look at the cost entropy of the based on the simply based on the output, it may not be truly reflected on how confident the LLM is because of the randomness of how it was the question. So first it cluster into a semantic based on the semantic meaning, and then take the entropy of cost entropy of the answer. That should give you a better judgment on the on how the model is to the answer. So again, this is to check how certain it is. Here's just a quick showing the results. Their semantic entropy is pretty much this just the usual coarse entropy using the cluster CI as the each category in after clustering. And it does show a promising result, which is the first field. Semantic entropy and discrete semantic entropy is what they propose with slightly different definition, and that outperform the if we just taking the entropy and or if we just simply compare to the other baseline they have other paper has proposed where P true is simply just a it was proposed by another paper which is by prompting asking model to say to say itself how confident they are with the answer, and of course that outperform that. And then the other two regression is just by taking that into regression. All right. So that's the two different types of hallucination detection. And the next one is the next types of hallucination detection method is the model probing. So this look into more into the architecture of the model. So currently, majority of the research I have seen from doing the literature review is that they all, many of them are doing on prompting, because not all LLMs are accessible. Like lots of them are black box, like OpenAI, we don't have the access to that. So they didn't have the option, but to just using the prompting to estimate and detect hallucination. But for the cases, if we do have the access, aka white box, we can use other method to probe the model itself, and hopefully that give you better detection on hallucination. I think some of the example here, for example, we can build a classifier based on the hidden layers. That's the one I'm just going to go through. And then the other examples, such as looking at the confidence activation values for the yes and no. That's, for example, if we give a query and the answer yes, if it's correct, or no, it's not correct, then we can actually look into what are the activation value on each of the pair to see how confident they are. If it's almost like 50-50, then we know that model is not confident. And then lastly, we can also look at how is the prediction actually come from by create a function on how prediction is by each of the input token. So if the input token was from some very irrelevant words to the prediction, for example, what is the presidency of, again, going back to the same question, who's the current president, and then if the is the major contributor to the prediction, then we know that it's probably not reliable, because it doesn't really have much to do with the question at all. The example I'm going to go slightly more in detail is the paper using classifier. So in this one, the paper hypothesized that the we all know that the large language model have multiple layers, and each different layer may actually contribute to how the model believe whether this this statement is correct, true or false. So, and like, for example, if we look into large language model, often the very last hidden layer is really about how to sentence the question, whereas the more abstract definition is often happening in earlier layer. So by sampling different layers of the hidden values of each layer and put that into a classifier, we may actually be able to pinpoint, or more or less like answer the question based on all those hidden layer, and maybe that will give us better meanings. So this is what the paper suggests. So they just selected layers from different stages, like from the last layer to the fourth last layer to certain amounts of layer, and then each of them put that into a classifier with 5 hidden layers, and train a classifier separately on that and see how accurate the answer is. And this, I believe, is a fairly preliminary result, because they can't choosing randomly in the choice of layers. And then they give for different category, they have according to this, the earlier layer, which is the 16 layers, has the best accuracy on the predictions, and also this classifier in general is actually giving better accuracy and AUC if comparing to a naive model from birds, or even a 5-shot or 3-shot methods. So it's not, yes. So I believe, again, this is fairly preliminary research, but this shows some promise. So here, these are some of the detection method I've shared with you for hallucination detection. And now we're moving on to mitigation. I'm just going to briefly talk about it. There are lots of, again, since hallucination does exist and there are methods to detect, then the next thing is how we fix it. Again, this can be done in many different stages. Starting from data, if we have more quality data, by filtering it properly, by just higher annotation, more accurate annotation, etc., we can eliminate certain hallucination. And also there are attempts on, if the app layer that's just buggy, there are attempts on detecting which layer are there and perhaps just edit it or create a hyper network just overarching the model to mitigate the hallucination before it comes up. The other method is the RAG. We all perhaps already heard about it. It's a yeah, there's many many works on this retrieval argument generation, which improve the accuracy on hallucination and the quality of the outputs. These are on the data side, and also we can also improve mitigating hallucination in the training phase, which, for example, just give a better architecture, which we have still seen lots of attempts in either the on model architecture, again on either on the how the training document is prepared, and in here is, for example, there were papers suggesting by rearranging the order of the document for training and cluster in similar document together, and before doing the pre-training, it will actually give better accuracy, because just like human memory, if you are just being fed with random knowledge all over the place, you may remember less than if you have been feeding into the top document with similar topics. So that may help for hallucination. Labeling techniques, again, that's for human annotator. If we have more better way of labeling. And activation. So for example, if we improving the activation value for that, again, it's in the training phase. Or we can, and other types of mitigation technique we can do is we can improve during the inference stage, where we have, for example, just like the self-detection method we have proposed before in the detection. If we ask the model to fact-checking its own outputs by asking indirect questions or asking questions on the smaller atomic facts, LLM may mitigate the answer itself. So, and there are several different methods that can do that. After the answer is reproduced, it can self-evaluate. And then similarly for faithfulness, if there are one of the technique, for example, is that if we actually looking at the if we ask a query based on the context given, we don't know how much is it actually fabricating the answer itself, or it's actually using what we provide as in the context. So what we can do is we can just produce two separate outputs, which can first we feed them the facts, just like I don't know, something like which city is our QUT located at. It's in Brisbane, and maybe this is the context, and we can ask the model to answer this question with or without this knowledge being fed to them, and see how much and whether it varies in probability in the answer. So that's to test whether it's staying with the context or not. Okay, so that's the quick go through on the various of mitigation methods on hallucination. And then now we just do a quick sum up on the what I have just gone through. So in summary, LLM that can generate hallucination, either incorrect or they fabricate information, or basically just differ from what we have asked it to do so, faithfulness. And it can be classified as factual or faithful or intrinsic, extrinsic, depends on the definition. And then the hallucination can be due to the training data bias or uncertainty in the model and some other different possible reason. There are different detection techniques, including fact-checking, uncertainty estimation, and model probing, and not limiting to that. There could be more. And there are different variations of mitigation technique, including improving data, RAGs, architecture, different decoding techniques. There are a lot. And again, this is a new field and people are still developing different methods. So there could be more than that. Future direction, again, there are different methods being proposed, and there could be more robust hallucination detection. I'm sure there is, because even till now we often witness hallucination on the latest models still. So there is still a lot of work to be done. And if many of them, the challenge is that the model often is a black box. We cannot see we can't explain how they have that, why the outcome is what they give us, and that goes into the field of XAI. So transparency will help a lot if we can have that for large language model. And the next thing is also there is a lot of work need to be done on identifying knowledge boundary. Basically asking question that if we ask question that the LLM didn't know, they should just tell you, I have no idea. But whereas often what we will see is that the model is overconfident and believe what they actually know, and just give you answer that they don't, like they fabricated. And that concludes my talk. So hope you enjoyed that, and hope you understand what large language model LLM is. And I will pass this back to Richie.
Thank you, Stanley. It was a wonderful talk and the introduction to the new field. I'll ask if there are any questions you can ask through the chat window while Stanley is with us.
Sorry, I need to open web. Where can I
It's
see?
okay. I can see the chat here.
I will stop sharing screen, and maybe that I can be able to check.
Yeah. So I can see. I hope it was useful. So I wanted you to have a brief overview of the field in terms of how what is hallucination and how it can be identified. So these are some of the LLM's research directions, hallucination detection and mitigation. Also, a lot of research is being done on prompt technology, because as we see, the future of these technology is how do we communicate. The better we communicate, the better we get the response from. So a lot of research is being done in this area. So thank you so much, Stanley. Given there is not any burning questions right now, we will move to now the next session by Dr. Abul Bashar. So Bashar, I now hand it over to you. And so participants, just that today we will be finishing much earlier. So this is more question and answer and discussion kind of question. So I already kind of wrap up the session, giving you some thoughts in terms of impact of these technology on humankind, and all the atmospheric and how we do control the climate control and so on. And then Bashar is now going to take you to the new session I'm not sure whether you will have any quizzes or not, but once Bashar presents his presentation, will be there if you have any questions that the team can help. Thank you.
Thank you very much, Richie. Can you hear me? Hello?
Yeah, we can hear you, Bashar, and we can see you.
Okay, that's good. Thank you. Let me share my screen. So I'll be sharing this one. Okay, and then let me view left. Oh no, share again. Share the screen. This one. Put it here. Then this one should come here. Here I can find. Yeah, I got my chat, everything ready. I make it bigger. Okay, let me share the presentation. Okay. And you can see my slides as well.
Yeah, we can see it.
Yeah.
So DeepSeek, a very, very hot topic just coming from the oven right now. So thank you, Bashar, for presenting it. Even I'm very keen to hear because I've been traveling from the last few days. Yeah, thanks, Bashar. It's our pleasure to hear this really latest technology.
Yeah, thank you. You already know me. My name is Mahmoud Abdul Bashar. I am a research fellow at QT, and I'm working with Richie for a long time. And you already know my biography, so I'm going to skip it. This is our team, and this is the disclaimer. I'm straightly going to the discussion. So the introduction. So we know that nowadays large language models, everyone is talking about large language models, and we can see that the gap between large language model and general artificial general intelligence is becoming smaller. In other words, now people are thinking that there would be a time when we will see artificial general intelligence where a single model can do everything without relying on very specific different models. And to go towards that goal, one important component is post-training. Usually the large language model is pre-trained with a vast amount of unlabeled text corpus, and then that can only predict the next word. So it understands the documents and text very well, and it can predict the next word. But the problem becomes it may not be able to follow your instructions. So people post-train or fine-tune the model using some, say, question answer and different other kinds of instructions, so that model can follow it, give you the answer. So that's why we do lots of post training, and this helps the model to increase its reasoning capability. It can align the model with very specific values. For example, make sure that the model will not violate ethical things, or it follows different restrictions that are needed to follow to keep it safe. And also we sometimes post train or fine tune the model so that we can use it for a specific task. And for this goal, OpenAI has a series of models that are called O1 series. In that series, they post-train the model in a way that it can effectively do inference it can effectively do the reasoning task in inference time scaling. In other words, it take the large language model, do the post training through lots of supervised fine tuning and reinforcement learning. But the problem is their model is very large. Their model is very effective, right? We talked about it a lot, but the main problem is their model is very large. So training takes lots of computational power, so it is very expensive. And when you deploy the model, because the model is very large, the getting the answer takes a lot of time. Inference, making inference takes a lot of time. So people were thinking, especially DeepSeek was thinking, can we improve in that area? That means, can we utilize the computational power more effectively? So in that regards, and other research teams were thinking as well. So people try to use different algorithms. Some of them are reinforcement based. Some of them are different advanced search based techniques to improve the computational efficiency. But it looks like none of them could actually beat OpenAI's Zero-1 or those kind of models. So DeepSeek, they took the challenge. They explored the reinforcement learning in a way where they use rule-based techniques to explore the search space instead of utilizing supervised data. So what I mean, I will explain details in my later slides. So in this talk, I'm going to talk about the details of the model approach, how they trained the model, what are the findings and interesting things they got. I will try my best to keep it non-technical. I will use minimum number of equations and other technical things. Let's try to do that. As an overview, we can say that DeepSeek R1 is a new large language model with reasoning capability, right? So this model is based on DeepSeek V3 model. Like before DeepSeek R1, there were actually another model, DeepSeek V3, that was doing lots of interesting things and good reasoning capabilities and so on. But DeepSeek V3 was based on DeepSeek V3 base. That means the basic language model, or the fundamental model, and they did some fine tuning and other things to improve it to follow reasoning capabilities. So from that point of view, they identified something, and then they thought, let's do purely reinforcement learning without doing any supervised fine tuning and see what happens. Can it do the reasoning capabilities in a way that it can beat the larger models from ChatGPT and other companies? So you can see that the main component or the main magic here is happening through reinforcement learning. And during this exploration, they actually came up with two models. One is DeepSeek R1, which is purely reinforcement learning without any supervised fine tuning, um, uh, pure model where they allowed the model to explore and evolve through the reinforcement learning without any human feedback. And then that model had some did quite very astonishing job in many areas, like especially for like maths and logical thinking. But it had some problem, the output produced was not very human readable, and then there are some language mixing. So output were mixing with, say, English, Chinese, and other languages together. That becomes difficult for humans to read. So then they solved that problem through another model called DeepSeek R1. So we'll see the details of both the models here. So in the DeepSeek R1, So as I said, it was trained using large scale. Large scale means thousands of reinforcement learning steps, and then they didn't use any supervised fine tuning, right? So during this time they explored the chain of thought. So the idea was that uh, through this reinforcement learning the model will explore chain of thought and evolve evolved in its space, search space in a way that it can uh, it can break down a big problem into smaller sub problems, and through that it can solve the big problem, and also it will know how to reflect on its thinking capacity so that it can modify its thinking, right? So and then during this training they saw that it was doing impressive reasoning capabilities. It did a very good job in maths, logic, and code, as I said. And then it was facing problem of poor readability and language mixing. Then they said, okay, let's go for DeepSeek R1, like where they used multi-stage training pipeline to improve the reading capability. In the DeepSeek R1, they addresses the issues that were coming from DeepSeek R1, and also they enhance the reasoning capacity of the DeepSeek R10. So how they did it? Oh, another thing is when they did it, they saw that DeepSeek R1 actually gives a comparable result of OpenAI 01 series, especially the OpenAI 01 1217, that model. And that's why you can see there are lots of discussion happening. The US stock market got plummeted and so on. So in the multi-stage multi-stage training, what they did is they started with a cold start data set. Cold start data set means a reasonable small, not too small, but a and also not too big as well. So it is a reasonable amount of chain of thought data that they took the DeepSeek V3 base model, and then they fine-tuned that base model with a initial set of chain of thought data, right? Where uh, uh, this one helped the model to like know the basics of chain of thought, so that during the reinforcement learning it doesn't go for all the possible wrong directions and then come back. That might take a lot of time, and also that's why the output was not very good, human readable, and so on. So using this the initial set of COG data, or chain of thought data, it made a restriction or initial guideline for the model. And after that, they applied the reinforcement learning without any supervised data. So this step, like second step, was exactly same as DeepSeek R10 model. So they applied the rule-based reinforcement learning. So when the model converged, and then they took the model and then they fine-tuned with extra setup, a bit of large set of data, which is supervised data, supervised fine-tuning data, and also they actually collected this data from the DeepSeek R1 converse version through a technique called reject sampling. We'll discuss that how they did it. And after all these things, they again applied a small amount of reinforcement learning through some data from which are from human feedback. In other words, this fourth step is used to make sure that the model aligns with human preferences. For example, it doesn't give some sentence that can hurt some community values and other things. Interestingly, we had a paper, we submitted the paper in 2020 and it was accepted in 2021. In that paper, we used multi-stage pre-training technique to do the domain adaptation, where we say we have a set of a small amount of label data in the source domain, and now we want to adapt the model in a target domain where we don't have any label data. How can we do that? And we saw that if we start a pre-trained model in a very generic area, and then in multiple steps we progressively fine-tune the model to the target domain without any label data, and then we fine-tune the model with the label data in the source domain. It works very well. It gives you very good accuracy in the target domain. And it looks like when I saw this paper, DeepSeek's paper, I got very excited about it, because it looks like we were thinking in the similar domain long ago. Okay, so and then let's come back to the model again. So in the after training the DeepSeek R1 model, when training is done, they tried to explore the distillation capacity. So what they did is they took a number of dense models that are open source, freely available. So dense model means they already densed or distilled those models into a smaller model, right? So what they did is they took those models and then they fine-tuned those models through the data set they collected from DeepSeek R1 output. In other words, those models were distilled with the knowledge from the DeepSeek R1. And after the distillation, those small models were actually effectively following the patterns of DeepSeek R1, and they did very good job in various different domains. For example, question answering, and then and other things like chain of thought and so on. Another thing they observed is that if you take a small model and then you apply the reinforcement learning, uh, that can give you good accuracy, but it is not as good as if you distill the larger model into the small model. So if you distill the knowledge from a larger model into a smaller model, that can give you better accuracy. And another thing they tried to explore, but they didn't fully explore, is if you distill the knowledge from larger model to a smaller model, and then if you apply reinforcement learning, it can further improve the accuracy of the model. So that part could be a research area that people can explore. And in my opinion, the magic of DeepSeek R1 actually comes from the architecture of DeepSeek V3 base. So in this model, they applied a number of techniques and methods to utilize the computational power in more effective way, so that you can train a smaller model without relying on lots of GPUs, right? So in this model, this DeepSeek V3 base model, which is the basic or foundational model for DeepSeek R1. It is a pure language model, and it has 671 billion parameters. And you know that the Llama has around 500 billion parameters, so it is a little bit more than a Llama, but it is much larger, much smaller than what it is there in other large language model. For example, GPT-4 has 1 trillion parameters, so compared with that, it is like half of the parameters. And another interesting thing is when they were training the model, instead of activating all the parameters like in ChatGPT or like GPT models and things, they activate all the parameters. So training takes more time and it takes more cost as well, because computation happens for all the parameters. Rather than that, they activate only 37 billion parameters. That means only a fraction of total parameters for each token. So that's why during the training, you don't need to activate all of them. So training will be much faster, inference will be much faster. So that was one interesting thing. And how they do is they did it through a technique called mixture of experts. So they have number of, here if you see in the figure top right hand side, so they have mixture of expert. That means instead of using one one smaller portion of code, how to say it, so instead of using all the codes here, all the parameters here together, what they did is they split it into several sections or smaller models, right? And then each model will handle a specific kind of computation, so that they don't need to use all of them together, right? So that was the trick. And another thing you can see that this DeepSeek V3 base, it was pre-trained on 14.8 trillion tokens. That means it show diversity of tokens and text, right? So it had robust performance in terms of basic language understanding. And its input length was 128 kilobyte, 128K. That means 128 tokens it could take at a time. That means the context length was reasonably long enough to handle different kinds of complex problems. Another list of efficiency factors were that instead of utilizing 32 bits for floating point representation, they used only 8 bit for floating point representation. So this is like a fraction of the bits needed to do the computation. They used multi-head latent attention. So we know that what is multi-head attention mechanism, right? So in the multi-head attention mechanism, each head you have key, value, and query, right? So and then some of the models, they cache the key and value so that the models runs faster. But in addition to that, in multi-head latent attention, what they did is they projected the key and values into lower dimensional hidden space, and then they have a mechanism where they can project it back into the original dimension. So doing that, they can reduce the amount of memory required. So that further gave the model efficiency in terms of computation. Another thing was in the earlier versions of their model, I think DeepSeek V2, during that time for the expert a mixture of expert modeling, what they did is they added a extra loss in the model, so that the model distribute the computation over different parts of the experts or different parts of the parameters, so that one part doesn't get overloaded. But that had a consequence. Because of that extra loss, model were giving a bit of lower accuracy, because to some of the efficiency of some of the capacity of the model was wasted for load balancing. So in this newer version, DeepSeek V3 base, what they did is they used a different technique called auxiliary loss-free load balancing, where they didn't add loss in the gradient. Instead, they used a different mechanism to handle the load balancing. And another thing is that we know that in language model, what the model do is it predicts the next token every time, right? And if you predict only one token at a time, and you can see to produce a long document, it takes a lot of time. So what they did is they, instead of predicting only one next token, they predicted, say, P or K number of next tokens. So take three next tokens at a time, or 5 next tokens at a time. That also reduces their training time and inference time. Okay, so let's quickly see what is chain of thought, because this is the philosophy they utilized in the reinforcement learning to train the model so accurately. So chain of thought is you have a big complex problem, and then you split it or break it down into smaller sub problems, so small that the model can accurately do each of these sub problem without any difficulties. So for example, if you have a problem where you want to calculate the cost of 3 apples and 2 bananas, if the apple costs $1 and banana costs $0.5. So one thing as a human, we can easily solve this problem without breaking it down into maybe different parts. Or if you see the traditional language models or traditional models, they try to map this whole question into an answer. But in chain of thought idea, it will break it down into several sub problems. For example, calculate the cost of 3 apples. So 1 apple $1, 3 apples will be $3. Then calculate the cost of 2 bananas. 1 banana $0.50, so 2 banana will be $1. And then add these two costs together. So you add the $3 for apples and $1 for bananas. It is $4, and that the total cost will be $4. So you can see that how you can do the chain of thought to solve a complex problem and get accurate result. And this chain of thought is the foundation of DeepSeek R1's training capacity. Let's quickly see what is this reinforcement learning utilized, or how it is utilized in this language model domain. So in general, reinforcement learning can be utilized in many different ways. It is just a framework, right? So you can use it in different ways in different areas, robotics and other areas. They do it in different way. But in language models, they made some assumptions and make it much more simpler. So how it works is, you have the agent. So agent means the model, that your language model that you want to improve it for chain of thought, right? So it interacts with the environment. So environment can be anything that can give feedback. For example, it can be the human who checks the answer for the question and say okay, it is correct or not. Or it would be some rules, right? So you can write some rules that you can apply on the answer to see if the answer is correct or not. Or you can, for example, if it is code, you can take the generated code, send it to a compiler, and then you give the input output pairs and see if the passing through the code, if you get the output through the compiler. That can be another kind of environment, right? Or reward modeling. So the environment responds to the actions. Actions means the generated answer, and transition to new states. That means it will give you the new information about how what happened, like what is the answer status, right? And then provide the reward. Reward means whether it is good or bad. The generated answer is good or bad. So, for example, if the answer is good, we can provide 1. If the answer is bad, we can provide 0, and so on. And then after the feedback, the agent means your large language model that will take the reward and update the policy. So in other words, the policy is the model weights or parameters, right? And then based on that, it will improve its decision making capacity over the time. So here is one very simple example. The question is, this movie is, and then we ask the language model to give us the complete the sentence. So the next part of the sentence will be, say, really great, right? So it provides you this response, and then it goes to the environment or the reward modeling or reward function, where it will take the question and the response from the model and tell the model whether it is good or bad, right? So the reward model could be a classifier, it could be rules, some rules, or it could be human feedback, anything. So the GPT models like ChatGPT and those models, they use a kind of classification models where they train a classifier through some label data from humans, and then that classifier gives the feedback for the reinforcement learning. But in the DeepSeek R1, they use role-based technique. Okay, and then after that, after the feedback, uh, the model will need to calculate the loss or in a way that it can update its policy or internal weights, right? So what it does, it takes the reward. Also, it does another thing, which is like it takes the reference model. Reference model means the earlier model before you do the update in the model, and then the model that you if you consider that feedback, and then if you update the internal weights, and then if you see what is the difference in the parameter distribution, and then you want to keep the parameter distribution similar to the reference model. If the parameter distribution is significantly different, what will happen is the model will jumping from here to there, and your the model might not explore in a systematic way, and then it may not converge easily, so it may take lots of time. So that's why they use this scale divergence loss that will make sure that the model does not change abruptly. So, and then also consider the reward. Combining them together, they will update the policy or the weights of the model. DeepSeek R10, they use reinforcement learning on the base model. So base model is their DeepSeek V3 base. That is their base model. They took the base model, they applied pure reinforcement learning without any label data, and then for the reinforcement learning, they used a framework called GRP0 framework. I will discuss detail about that framework. And then after that, all the training, they get DeepSeek R10, right? So that was the mechanism from the very high level. And if we go a little bit more about how the role-based reward modeling was utilized, so you can see that the reward is the source of training signal. So reward gives you a signal how to optimize or change the direction of the reinforcement learnings so that the model gives better accuracy. The rural based techniques they utilized for this modeling, it had two components. One was accuracy reward, another one was format reward. So in the accuracy reward, they evaluated whether the response was correct or not. So for example, for the math problems, because maths is it is deterministic, so you have a question and then it generates the answer in a specific format. For example, it generates the answer and give it in a box. So then they use some rules, various rules to verify whether the answer is correct or not. Or if it was for lead code problems, then for a given problem, the model will generate the code. The code will go through a compiler, and then compiler will test the code against predefined test cases. That is input and output pairs. Another part was format viewers that make sure that the thinking part and the answer part of the model is separated out. So they restricted the thinking to happen in this tag called think, and then inside the tag will be the thinking, and then close the tag, right? So all the thinking will happen inside the thinking tag, and then the answer will be after the thinking tag. And then the motivation of them not utilizing neural reward based model like GPT models, they utilize this rule based model because one thing is if you want to utilize a neural reward model, That means you train a classifier or something that can give you feedback in the reinforcement learning setting. Then you need extra label data to train the classifier. Another thing is it is observed that if you have that kind of neural reward models, then through the reinforcement learning, your model or your large language model can figure out how to hack the classifier model. In other words, it can figure out what are the patterns used in classifier model to give you the feedback, and then it will try to mimic that pattern and then easily beat the classifier models. So that means your large language model will not learn enough or will not explore enough to make the answer or accurate answer. So it will not learn about how to apply chain of thought more effectively, right? So that's why. Uh, uh, yeah. Now let's see a little bit more about what is the algorithm utilized in this DeepSeek R1 model for the reinforcement learning. Let me use a pen. Point option, laser point pen. Yeah. So this one is called Group Relative Policy Optimization, or GRP0. Group relative, that means actually they use a group of feedback. That's why group relative. So what happens is in the traditional method, they use a critic to do the feedback. So the critic is usually as same size as the original model. So you need to run the original model and the critic, so the computational power will be very large. So instead of that, what they did is they estimate the baseline or from the group scores, group like scores from a group of feedback. So what happens is for each question, so given a question, they will this mechanism will sample a group of outputs or the response, or you can say answer to the question. So say O1, O2 until O0, OG. So from the old policy, that means the model you already have right, or already fine tuned, right? That original model. And in other words, actually, you have the original old model, right? And then in the optimization policy, so they optimized this model. They call this one. So the original model they call phi theta old, and then the updated one that they want to update, that one is called phi theta, right? So they optimize the policy of the new model by maximizing the following objective. So what they did is, see here. So this is where they updating the parameters like weights or parameter, whatever you call it, the theta. So they want to update the theta. How do they do it? They sample a number of outputs. So from the old policy, so they sample from the old policy G number of output, and for this one, what they do is they do several things actually. One is this thing called advantage, right? This advantage. So this is the advantage. So instead of directly utilizing the reward, what they do is they normalize the reward for all the generated output. So this one you can see here, they are doing the G-score normalization, right? Ri minus mean and then divided by standard deviation. So it is G-score normalized version. So this one they call advantage. Another thing is, so this is the main equation, right? This part is the main equation. So you can see in this part, you have two things. One is this thing. So what they want is the parameter in the reference model, and the updated model should be should be similar, not abrupt, not change abruptly, right? So they use the KL laws to make sure that it is not changing very quickly or changing to something that is very different than the reference model. So that's what they are imposing here. And then here actually they explain what is KL. All of us know what is KL. And this is another part where you can see what they do is they multiply these advantage or reward, right, with this ratio. So this ratio is the probability distribution generated by the new policy and the old policy. So new policy. This distribution is distribution for all the generated answer, all the right, all of them. Like you generated a G number of outputs, so for all of them. So you take the distribution and then take that ratio and multiply by the advantage. So that will make sure that in other words, you are actually taking the average. So you want to see if you take this decision, right? Uh, are you going to change very different than the average gain? So if you see this, the gain is very significantly different, that means it might not be a very good decision, because the new decision should be something near to the average, not very significantly different. So that's what it is ensuring here. So overall, it will try to progressively improve the model little bit in each step instead of going abruptly, right? So that is what we are ensuring. Okay. So now after the reinforcement learning, so what they did, they take the DeepSeek V3 base model, and then they apply this in reinforcement learning. And you can see after applying this, something interesting happening. First of all, you can see the accuracy. So DeepSeek R1 0 without any label data, without any fine tuning with label data, you can see the accuracy is 71%, which is similar to OpenAI 01 series, which is 74. Obviously, 74 is larger, but you can see it is very similar, not significantly different. And then what they did is they took the so this one is fast at one. That means they consider the accuracy of all the response. Like if it generates say 10 response, so accuracy of all the 10 response, average accuracy of 10 response. That's what it is. And then in the next part, what they did is they took the average, majority voting. That means if majority of the samples are saying say 3 as output, then they take 3 as the response. So if they do that, you can see the accuracy goes significantly better than the OpenAI 01 series. For other data sets as well, like maths, live code, and so on, you can see the accuracy is very close to the OpenAI models, right? And here they are. So I think this part, this figure here is very interesting. You can see. So it has two curves. One is if you take the pass at one, that means average accuracy for all the generated answers, and then the red one is the majority voting. So what you can see is it starts here, right? So this one is during your training. So you start the reinforcement learning, the accuracy is here. Around, I think it is around something. What is the figure? I have the number somewhere. Yeah, see here. So it starts from 15%, around 15%, and then it continues to improve the accuracy up, and then when it converts, the accuracy is 75%, which is amazing. Without any label data, just through reinforcement learning, it goes accuracy 75%. 71%, sorry, 71%. And for the majority voting, you can see the accuracy is here, 86%. This green line is OpenAI 01 model, and you can see the accuracy of this DeepSeek R1 and the OpenAI model is similar, very close, right? After that, and if you use the majority voting, and the accuracy of DeepSeek is better, right? That's very interesting. Another some interesting things they observe. So another thing is that as they continue to do the reinforcement learning, the response or the generated out becomes longer and longer and longer. So and then they monitor or they check what is happening. They saw that if the output or the generated text is longer, it is actually doing more chain of thought. Initially, it was directly mapping answer to the question, trying to map question to the answer, directly mapping, and then it starts to do the chain of thought bit by bit, more and more. And then as it goes throughout the time, the response goes bigger and bigger, more text generated, and they saw that there were more chain of thought, more observation, reflection, and so on. And another thing is it was directly correlated with the accuracy. The more thinking it gives to the question, and the more accurate answer was generated. So that was fascinating. And after that, they gave an example of aha moment. So this is they called aha moment. So what happens is, see this in this example, give this is a question. The question says if a is greater than 1, then the sum of the real solutions of root over square a minus root over square of a plus x equal x. So you need to solve this equation to find out the value of x. Now the model tries to solve it. So it says, okay, let me think to solve the equation. So all the things are generated from the model, directly from the model. It says to solve the equation, we need to solve this equation. This equation. It says let's start by squaring the both sides. So it takes the square for both sides, so that will remove the first square root and gets this part. And then it says, okay, there is another square root in the middle, so it says rearrange to isolate the inner square root. So it rearranges it, right? And then it tried to solve it. So it goes this way. And at this stage, it thinks, okay, I did this way, but it looks like I can do it better. So it says, wait, that's an aha moment I can flag here. Let's reevaluate this step by step to identify if the correct sum can be, and it gives other things. So they omitted that part. And then it says, we start with the equation. So this is the equation. First, let's take the square root of both sides. And next, I could square both sides again, and so on. So you can see this is much simpler solution than the first step. So this is very amazing how a machine can evolve through reinforcement learning to generate the chain of thought to make the answer, and also reflect back to improve the chain of thought itself, which is really, really fascinating. So as I said, until now it was good, but the problem is it has issues of so it is not human friendly, right? And also language mixing. So they said, okay, let's try to solve that problem through cold start data. So this is the so for that to solve that problem, they come up with DeepSeek R1. So it has several steps. It has 5 steps, and you let us explain what is happening. So in the first step, they take the base model DeepSeek V3 base, and then they use this cold start chain of thought examples, human labeled. And after that, they do this reinforcement learning. And this reinforcement learning in step 2, it is exactly same as they did for the DeepSeek R10. So exactly same reinforcement setting here. After that, so when this reinforcement or step 2 is done, our model has converged, so they take the checkpoint out, and then they run it for some set of questions, say many say question answers, and then after that they ask people to check which question answer are like which generated question answer or the generated answers for the questions are valid. So this part they call reject sampling. So if the answer is or the sample is correct, keep it, otherwise reject it, right? And they got some number of answers, and then out of that they fixed some of them. So for example, maybe language was mixing, or there was little bit of lack of clarity here and there, so they fixed those things. So in this process they end up with 600k quality reasoning question answer pairs, so our quality reasoning task. So this part, and then another part, this 600k is purely reasoning, but it needs to have some general capacity as well, right? So what they did is they added 200k non-reasoning examples. Those are like facts, question related to facts, writing, and so on. This 200k came actually from a fraction of data from DeepSeek V3 model. So during fine-tuning the DeepSeek V3, they collected a large number of human level data. So out of that, they took this 200k. So altogether, they have 800k data, and use that 800k data points to fine tune the model. So after the reinforcement learning, they took the model and then they fine tuned the model with this data set. So this when they got the model was doing nice. But another issue was they wanted to make sure that it doesn't go against community values, right? So they it should not say something that are racist or harmful. So they added another small set of data, and then like human level data that are related to those community values and some other small reasoning things. And then they trained a classifier kind of model, like a neural network model, and then they again did a small amount of reinforcement learning over the model, and finally they end up with DeepSeek R1, which is the model that we are all of us talking about. After this one, see here at this stage, you have 600k plus 200k. This 800k, this is actually, especially this 600 actually, more specifically, this 600k actually coming from DeepSeek R1, right? After the reinforcement learning, you got this 600k. So this part and this 200, so 800 together. They use this 800k together to fine tune some of the dense models like Quen 1.5, 7, 14, 32 billion, and also Llama 8 billion and 70 billion, and those models. So they fine tune those models with this amount of data, and they saw that they can actually follow some of the patterns in the DeepSeek R1. And then they actually perform significantly better than existing distilled models used in the community, right? So they call this distilled R1 model. Okay. So we explain this part. Yeah, explain this part as well. Okay, so done. Yeah. Now let's see the performance for the DeepSeek R1 version first. You can see overall. So this is these are the models they compared. So this is DeepSeek R1. This is their model, and then OpenAI 01, OpenAI 01. The two model OpenAI from OpenAI. One is 011217, another is OpenAI 01 Mini. So these two models. And then here you have DeepSeek V3, which is like their earlier version of the model. Also, they have GPT-4o model, They have Cloudy 3.5 Sonnet. I don't know about this model actually. Anyway, so for all these models, you can see for different things they have different accuracy and so on. And then I summarized actually those things here. You can see for the educational data sets, DeepSeek R1 actually outperforms the DeepSeek V3. So, and then and also especially they're saying STEM related questions. It did excellent for STEM related questions and other education related questions. And then it was giving similar performance for this math related task and SWE verified dataset. So for these two dataset, it was giving similar result as OpenAI 01 version. And also it was giving excellent result from frames, which is long context dependent question answer and simple question answer. And you can see there, and obviously you can see overall it was doing significantly better than other models and so on. But it had some limitations for some dataset. For example, it was performing worse than DeepSeek V3 on Chinese question answer, and they are thinking that it might be because of the safety features they imposed on through the reinforcement learning that might be hurting the Chinese question answer part, because yeah, they applied lots of rules and regulation there so that it doesn't go against community values. And another thing was that for engineering related data, it was not doing very great. So they are thinking maybe if they apply reinforcement learning for that domain, it may give a better result. And here are distillation result. You can see for this model, DeepSeek R1 distill llama 70 billion parameter, this model. So when they fine-tune this one with that 800K data points, you can see for all of them, it is significantly better than other models, except for this data set here and here, right? But you can see for this dataset, the best result is again from the distillation, and it is coming from this QWEN 32 billion parameter. Only this part was doing better. The original model, sorry, OpenAI 01 mini, that one was doing better only for this dataset. So overall, you can see distill model are performing significantly better than all the other distill model like GPT-4, Cloud 3.5, OpenAI 01 mini, and so on, right? So this is interesting, and that's why people got excited. People are testing with all these distill models. And I saw that some people are running these models on Raspberry Pi, and my friend, he was running on his laptop, and so on. People are testing all of the things. So so they're thinking that there could be potential further gains through distillation here. So if they take a distill model, like say take this model and apply a little bit of reinforcement learning, that can give better result maybe. So the people can explore that area of research. So overall, we saw that DeepSeek R10 uses a pure reinforcement learning approach without label data, and it achieves significantly better performance for chain of thought exploration. And when they applied cold state data and multi-stage multi-stage training, they achieve a performance which is comparable to OpenAI's very large model, right? This model is very large model. So compared with that, they they train a very small model that can give similar accuracy. And also, to train their model, they only needed a fraction of money compared with OpenAI 0.1 training. And another thing is that we can see distillation has a significant potential. So people will now start to test all the distilling techniques and so on. Thank you very much. If you have any questions, I'm happy to answer them.
Thanks, Bashar. Thanks for the wonderful talk and really insight on a very, very latest model. So, Bashar, you can check. There were some questions on chat.
Okay.
So you can check and try to answer some of the questions. And today there is no hands-on. Once this session is over, I'll hand it over to Namita to conclude the module and conclude the program. And if you have got any other questions, please write it in the chat and see how we can help. Bashar, you can unshare.
Okay, I will stop the sharing.
Yeah, and see the chat. And I'm welcome to India. There is no electricity in Roorkee, where I am right now. I'm hoping my battery would last for the extra half an hour or so.
Okay, so some of the questions actually needs a very detailed discussion. Yeah, those are not directly related. For example, how chain of thought is different from dynamic programming, those kind of things.
And also, like, there is a question that is there any work on graph-based transformer?
Okay. So for graph-based, yeah, it is. I believe it is possible, but I didn't see any significant model yet. And what I think is, until now, people were like guessing about how OpenAI trained their model because they didn't release. They were closed models, so people are thinking different things. They are trying different things. Now that DeepSeek, they release their code, release their technical report, release all the train models and everything. So now people know exactly what is happening there, and now people will try to learn these techniques and apply in different areas. And I think we'll see boost in different modeling, like graph-based model and other things, where people will try to use these kind of things. And I think this is a good question, that can graph-based technique be improved through this kind of reinforcement learning. And I believe it is possible because chain of thought is in a way similar level of similar style of thinking of graph-based, even though graph-based is more formal, but the goal is similar. So I think we will see some boost in graph-based modeling as well.
Yeah, and if I add to it, we have used graph-based, not exactly with transformer, but in the recommendation research for Stephen. So graph structure, the same thing I have used in one of my transport project with transformer. Usually GNN or graph-like structures are used to learn the spatial relationship. So this kind of reasoning and learning becomes important when you have spatial information or any similarity based information that you want to attribute into your model. So the graph based structure can learn the similarity or can learn the spatial similarity, and then that could be encoded in another deep learning networks.
Yeah, there is another good question. It says, but a model gives same answer every time for the same questions. Then how the group of output will be sampled? So the idea is that for a mathematical problem, right? The question and the answer will be obviously same answer because it is deterministic. But the chain of thought will be different. So same problem can be solved in different ways. I saw one example where they explained the aha moment, right? So same for the same question and the answer, you can explore different chain of thought and different way of solving it, and that's why the answer is different. Like chain of thought part will be different. That's why you can sample different answer for the same question.
Okay, you can also ask any questions on any of the previous modules while some of us here, and we will try to answer your questions here. But I welcome all of you to visit our group page. Each of the module materials, the links provided, the research papers that we have published, and I welcome you to contact me, and then I will redirect those questions to any of my group members who they direct to. So I would welcome to receive your questions by email, but please keep in mind I am on leave for a couple of weeks, so my response would be slow, but I'll try to forward your links and things like that.
There is another question. I think that is also interesting. While using a classifier for feedback for a keyword, we need to ensure it is 100% correct. How do we ensure that? So to make you can see DeepSeek R1, the answer they got is 100% correct because it is role based, right? So that's why in that part accuracy was really good. On the other hand, if you train a classifier model, obviously it is going to be some percentage of accuracy, say 80%, 90% or something, and there is a portion of uncertainty there, and that obviously that will get reflected in the model. And this is one thing. Another thing is the reinforcement part of the training is to explore the chain of thought part. So even though there is some uncertainty in the answer, but it still knows how to explore that part. And after the exploration, you can fine tune with accurate data like human label data that will compensate some of the uncertainty in the model.
And it's great to see the collaborative question answer going on. So I guess that is the purpose of this platform and this program, to connect to each other. So even within yourself and within the networking, you can find the collaborators.
And the question is there any way by which chain of thought rules can be generated automatically? So what they did in their model, say, especially in the second part, like DeepSeek R1 part of the training. So they, in the first part, they trained it like with some cold start and then did the reinforcement. After that, they asked the model to generate some chain of thought rules for different question answer, right? And then they checked the answer and saw which chain of thoughts are correct or not. So based on that, they use those data to fine tune. So that means obviously you can use that approach, or another approach is you can take the DeepSeek R1 model, which is now very accurate. So you can take that model, generate your chain of thought automatically, and then for some specific areas for your need, you can maybe check some of a small portion from there and then update the model again. That can give you accurate result.
There is a question that, is it true that DeepSeek model manufacturing cost is very low as compared to other LLM models? At least the reported cost is very low. That's what I would say here.
Yeah, so for OpenAI 01 model, the cost was around roughly say $500 billion. On the other hand, for DeepSeek R1, the training cost, like the one pass training cost, that part that costed only around $6 million. So which is a very small portion of the cost needed by large models.
And it is also projected that it's not just the manufacturing cost, even the operational cost. Like I was reading somewhere, they are anticipating that it's a $7.50 cents per minute for OpenAI models in comparison to 15 cents for the DeepSeek model.
Okay, so another question was, what is the difference between dynamic programming and chain of thought? From high level, in chain of thought, you can see chain of thought try to, it is like when we to try solve to solve a problem, we think in our head. So if you say out loud what you are thinking during solving a problem, so that is actually chain of thought. So which is more of a thinking pattern. It is not exactly a methodology like programming solution. On the other hand, in dynamic programming, you obviously there you take a big problem, break it down into a smaller problem, but the idea is you save some of the solution in your memory and then reuse the solution next time, right? Which is like caching technique. You cache down the solution. In say chain of thought, you do not save anything. But so you simply learn train the model, or the model learns how to make a better chain of thought, but it doesn't save anything to reuse during the training. So it is completely different than dynamic programming.
Okay, so I think I'll take this opportunity to wrap up the module, the session today, and the program. And I like to thank my team. Extremely grateful to present such a high quality and latest up-to-date material. I hope that you are able to use them in future for your research. So when you use them, please cite our work. As you know, citation is very important in our research field as well. And open for collaboration as well. I know you have got some excellent ideas in there. So, and I like to take a sincere thank you to Namita and her team as well at the local front, running this course without any hurdles, without much barrier, and especially Namita to take the initiative and offering this course. On that thought, I hand over it to Namita. Thanks, Namita, and thank you so much again to the entire course team, and the most importantly to participants. Without you, these courses are never possible. And we always are saying in between us in QUT team that you guys are so engaged, so thoughtful and respectful. It was, we were always looking forward to come every weekend and present our course.
Yeah. Thank you, Riji. Thank you, Dr. Pasha. So I'm so happy that we are concluding the program today with great efforts of the speakers, especially Riji and her team. So it's very insightful for everyone. So we are getting good feedbacks so far from the WhatsApp groups we have at the local academies. So as people are asking that today's lectures, you can see it again from the YouTube videos. Those are available. And about the quizzes, 2 quizzes are mandatory only out of 4. 4 are meant for those who have missed first, second, third anyhow, and only 50% marks will be checked. No need to worry. It's average of 2 only, best 2 only. So anyhow, everyone who have attempted will be qualifying. will qualify it. And we are keeping a watch on the WebEx attendance also, so no need to worry about that. And thank you everyone who have attended, who delivered the, especially the team, Richie team, all the Deepak, Bashar, and Joy, Wong, everyone. Thank you so much. Sorry for this. I'm not able to on my video due to some technical issue. Thank you, everyone. Thank you.
Thank you. Then good luck with your future career and future endeavors. Hope you do a lot of good research in AI and we see your names in the publications. So thank you very much. See you guys next time. Bye-bye.
So all the participants, please be available for the quiz if you wish to attend. It's not compulsory. It's only, it is made for only those who have missed it. So in case of need, kindly contact us. We are available here.